Hey, pre-calculus, we've got Unit 3, Lesson 2, and so we started today by taking some notes instead of focusing on the way the lesson starts out. Anyway, you got the answer key for the matching up stuff. We're going to focus on the homework, of course. So in class, we either did a Kahoot or we had the opportunity for you to do some matching of some like paper cards and stuff like that, matching graphs up. It's all about transformations, and so we got different forms of the exponential function. Remembering our parent function is just some base being raised to some power, some number here that is greater than 0, but not equal to 1. So it could be between 1 and 0, not equaling 0, not equaling 1, or it could be greater than 1 whole. Representing growth or decay. Anyway, for those kids who weren't in class, or a few of you, you should look at the picture of this and get a copy of these for your own notes. And yeah, let's jump into the homework. All right, and let's make our answer key. So today was about transformations, moving things up and down, and this first one just says find the x and the y intercept. So I mean, really zoom. The x and y intercepts are going to be relatively easy to find. So here's the thing, is that this is not being shifted. So if we had like our y equals 5 to the x power, that would have a horizontal asymptote that would be y equals 0. It wouldn't touch the x-axis unless we had another number added or subtracted onto this. That would shift it up or down and shift where that is. So because of this, there is no x-intercept. There are no x-intercepts at all. However, there is a y-intercept, and so you just go ahead and put 0 into the function. 2 times 5 to the 0 power. Anything to the 0 power is equal to 1, so we just have 2 times 1, which is 2. So at 1, 2, that's its height, that's its starting value, and then it's going to be growing 5 times each time. So 2 times 5, 10, and then 10 times 5, 50, and that's going to grow. So our y-intercept, that's it. Our y-intercept is that too. Okay, anyway. So we got this graph. There's been a transformation here. So remember our transformations of functions. If this was y equals 3 to the x power, that would be our base function for this, kind of like the parent function for this. But the x has a -2. So remember, anytime we're affecting the x variable with a plus or a minus, it's going to be a shift left or right. So here's the thing. I'll do this in red, this one, and then we'll do that one. So if this was 3, so 3 to the power of 0 would be 1. 3 to the power of 1 would be 3. So we got 1, 3. 3 to the power of 2 would be, so 2, we would be at 9. So 3, 6, 9. Yep. And that would be our graph like that. And then also 3 to the negative, a negative 1 power would be 1/3, and then 1/9 and all that jazz. So so in red, this isn't the graph of the equation they wanted us to graph, but this is the graph. There's our horizontal asymptote. In purple, graphing this one, well, a -2. Remember, if this was y values, it would move up or down according to the sign, but it's the opposite sign. So each of these is going to move 2 units this way, 2 units this way. This one's going to move 2 units to the right. So everything. So everything is going to move 2 units to the right, and so this is where we should get this graph. This should be precise. You should be locking in specific points. It's not a sketch. The in between these points are sketches. This one at 1/3, and then beyond is a sketch. Test or quiz time. I'm going to want you to have exact values for that. Okay, all right. So by the way, that's one way of doing it. You could also make an x and y table and put in different values for x. You put in 0 and you get a negative. Put in 0, you get a -2, and you'd have 3 to the -2 power. You put in 1 and you'd have 1 minus 2, which would be 3 to the -1 power. Put in 2 minus 2 would be 0. You'd have 3 to the 0 power. So at 2, we get 3 to the 0 power, which is 1. This is another way that you totally could do that. Let's move on. All right, so describe the transformations that occurred to this function. There's our base function to give us this. Okay, so if we got that, so what's happened? We have, this means that it's going to be, and that is a translation. So this is going to move left 1 unit, and down 5 units. And this means that there's also going to be a vertical reflection across the x-axis. All right, so that's all the stuff that's going to be happening to that. Let's move on. This 1/3, find the y-intercept. Well, put 0 in here, it's going to be 1. So it'll be, when you put 0 in, you're going to get 1. It's going to have that same y-intercept. I'm going to zoom out. The questions seem to need a little more room. All right. Which is greater, f at -2 or f at 2? So 1/3 to the -2 power versus. It's like we're playing, like, I don't know, a combat game. 1/3 to the second power. So what does this mean? Well, 1/3 to the second power, that means 1/3 times a third, which is 1/9. Okay. What does this mean? Well, this means we're doing 1 over 1/3 to the second power. That's what a negative power means, and that's the same as 1 over 1/9. Now that's a complex fraction. 1 divided by 1/9. How many times does 1/9 go into 1? It goes into it 9 times. So which is greater? Definitely that one's greater. And then it says graph f of x on the grid provided. Well, here's the thing. Now we've got 2 inputs and outputs here. So we have, we have that x and y. When x is 0, we got 1. When x is -2, we get an answer of 9. And when x is +2, we get 1/9. My penmanship is not the best today. So 0, just graph it. 0, 1, great. Go to -2, and we're going to have a value of 9, 5, 6, 7, 8, 9. I'm going to do that. So that I can swoop it in. All right. By the way, 1/3 to the 0 to the, that would be 3. So -1, we would be at 3. And at +1, we would be at 1/3, and then we're at 1/9 at +2. We already know that. So there's our exponential decay curve drawn roughly to scale. All right, we're in that horizontal asymptote. Boom. Okay, flippity flip. Again, all of these are skills that you should have for working with these. A lot of this is review from Algebra 2. I honestly, really, in the Algebra CP class, we didn't do a lot of transformation. We didn't really do transformations of exponential functions. So that's new, but it's not rocket science. So identify the y-intercept of the graph, g of x. So what's the y-intercept? All right, well, so here's the thing. It's the value you get when you put in 0 for this. 6 to the 0 power is 1. 1 times 2 is 2. 2 plus 7 is 9. The y-intercept is 9. The y-intercept would be this number, but it's being shifted up by 7 units anyway. Identify the horizontal or vertical asymptotes. So here, it's going to have a standard vertical, horizontal asymptote, not vertical. It would normally be at y equals 0, but because we're adding 7 onto it, it's at y equals 7 is our horizontal asymptote. What is the domain of that, of g of x? Okay, so domain are all the inputs. What values can we put in for x? Honestly, on the x-axis, we could put in any number greater than 0, find its power, then multiply by 2, then add 7. This is all going to check out. Putting in 0 also works. Put in 0 and we get a value. And even if we put in negative numbers, when we start putting in negative numbers, that's like, 1 over 6 to whatever the power is. We'd get an answer for that. Fractions, small, very, very small numbers. The graph is gonna approach like that, except the y-intercept is at 9. That represents 9. Anyway, it's all real numbers. The domain is all real numbers. When we look at what is the range of it, well, the range is going to be all real numbers, such that g of x is greater than but not equal to 0. All right, so that should make sense. No, not 0. Not 0. Our asymptote is at 7. Is at 7. So, yeah. You could also express. I'm looking at the answer key. Answer key also has this expressed in like this interval notation like that, from 7 to positive infinity. You can write that. That's fine. Okay, number 6. Here we go. We got a graph. All right. For 2 to some power, some constants a, h, and k. Find those values. Okay. So here's the thing. I am not seeing, so since it's 2, we would expect exponential growth. Check. That's working. That means A is positive. So A is equal to a positive value. Is it getting shifted left or right? So here's the thing. If we had 2, let's do some numbers here. All right. If we put in 0, 2 to the 0 power, all right, we would expect to get a value of 1. 2 to the power of 1, we would expect to get 2. 2 to the power of 2, we would expect 2 to the power of 2 is 4. 2 to the power of 3 is going to be 8. These, I gotta get the light back on. These are the values that we would expect to get. All right, so here's what I'm going to do. I'm going to break out a little piece of patty paper here and graph. So 0, 1, 2, 1, 2, 1, 2, 2, 4, 2, and 4. There's our growth pattern right there. So that growth rate right there, and -1 going to 1/2, that growth pattern is something I want to find. Where does that growth pattern lock in place? It locks in place right there. Okay, so let's keep this in mind. This point should be, man, my brain ain't working here. Oh, there we go. No. Oh my gosh. Why ain't my brain working here? 2 to the power of 0. My head ain't working. Hold up. Did I just mess this up? Oh my God. I just messed. I'm losing it here. Let me draw on the axes. My God. All right. 2 to the power is 1. 2 to 1 is 2. And 4 and 1/2. My gosh. My brain. There we go. Okay, so this point should be here. But what we saw is that point is down here. That is going to help us get that it's moving right 3, which we would express as an x minus 3, and up 4. Oh no, down 4. Okay, so let's look at this. This is going down 4, so a minus 4, and left. Okay, that's the start. This is where it is now, left, so that's going to be a plus 3. There we go. Okay, so now we got it. Here's the thing. Because this locked in, that means that there's no scale factor that's stretching this or making it larger or smaller or anything. So the A value is just a positive 1. The H value, okay, so we got this. The H value is going to be a negative 3. H is equal to negative 3. When we put that negative 3 in and put a minus sign in front of it, that's where we're going to get our plus 3. And our K value is going to be a negative 4. Awesome. There we go. Great. All right, so let's move on. Consider this function. Okay, and these functions here, complete the tables. There we go. Okay, so complete F. -2. All right, let's start at 0. Put 0 in here. That's 1. We get 1/5. 1/5. All right, put 1 in here. 5. Ooh, to the first power. So that's going to be 5. That's going to be 1 whole. And then 25 divided by 5 is 5. And then 125 divided by 5 is just going to take a power of 5 away. So it'd be 25. I love that. I like that. So each time we're taking 5 to the power of x and we're dividing it by a power of 5. So it's the same as 5 to the power of x minus 1. That's interesting. So, all right, so the way these would then work is that then we would have 1/25 and 1/125th, because this f of -2 would be equal to 1/5 times 5 to the -2 power. But that's the same as 1/5 to the +2 power, and that's the same as 1/5 times 5 times 5. 2 of those 5s from there, 1 of the extra 5s there, and that's 125. Okay, g of x. Hit, ha, 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 ha. Same. There we go. So look at this. So like that little bit of thought of like what is happening here and what's an alternate way of expressing it. That is an alternate way of expressing it. What do we notice? They're the same darn thing. They're all right. Why do you think this is? It's just the properties of exponents. All right. Let's see, what's the answer key say? I didn't even look at this. I never look at this. You know me, I always do these from scratch. So for number 7, two functions look alike because they're the same. We can verify that by noticing that because the common ratio is 5, multiplying by 1/5 eliminates a factor of 5, yep, which is equivalent to lowering the power of 5 by 1. Vertical shrink of 1/5 is the same thing as a horizontal shift. 1 right. Actually, that's interesting. I really like that. That connection to transformations. That's interesting because that's what we're doing. This is that vertical shrink because we have a scale factor in front of this. This, as a transformation, is moving it 1 right, and so they're saying that those are mathematically the same. Now that is making me think here that moving something left or right is the same as a scale factor. I am willing to bet here that there might be other answers. Maybe there are other equivalent answers to that. Okay, by actually having a non-1 value for A. Let's move on. Maybe someone could wow me by showing me that, but nobody's going to really watch this video. It's just me. Identify the transformations that took place from the parent function y equals 3 to... Okay, so here's, again, if we had 0, it'd be 1. 3 to the 1, 3 to the 0 would be 1. 3 to the first power would be 3. 2 would be 9. Okay, so let's look at this. I'm looking at a parent function that would be starting out. Let me get my axes and learn from my mistakes. At 0, 1, and then 3, and then 9, and then also 1/3. So I'm looking at this as I take this and flip this here. So I want those points to kind of like line up. I'm watching this point, and as I shift it and have it travel down the line, I'm shifting it until things match up. There we go. There's our growth factor. So let's keep track of a point. How about this one right there? All right, that should be here. Okay. So what's the transformation that would take the curve that should be going through this point, but it ends up over here? Okay. I think an easy way of doing that would be a vertical reflection. All right, so we do a vertical reflection, bam, and then a shift of right 4 units. I think that's the easiest way to express it. There could be other equivalent ones, but I'm going to say identify the transformation. So I just said them verbally, but we could write this as y equals a negative 1 times 3 and a left or right, so minus 4, x minus 4 power. That seems to be a way of writing it. Answer key doesn't say that, but that's fine. That's fine. They just said it in words. Explain why this graph and this are identical. Well, so here's the thing. Anything to the power of negative x is going to be equal to 1 over that same thing to the positive power of x. And anytime we have this, see, here's the thing, is that couldn't we also write 1, or let's work with this, 1/7, that x gets distributed to each of these, 1 to the x power over 7 to the x power. So I'm taking this and transforming it this way, taking this and transforming it this way. 1 to any power is just going to be 1, even 1 to the 0 power is 1. And so we get something that is mathematically equivalent, 1 over 7 to the x. So that's one way of explaining it. Write the equation of an exponential function that passes through these points. Okay, let's look at this. 0, 1. Okay, so we're at 7 and 22. Has a horizontal asymptote at y equals 4, so that means I'm going to have a y equals something times something to the power of x. Maybe something else is happening here, but we got an asymptote, horizontal asymptote. Ooh, that's at plus 4. Boom. So there's going to be a shift from y equals 0 to y equals 4, moving it up. Okay. Now, exponential. So here's the thing. If it's exponential, that means we're going to be multiplying by a scale factor. All right. 7 to 22. That's not so nice. There could be more than one answer that works for this, but I'm going to end up using, all right, 22 divided by 7, which is, it's not a nice number. Oh man, that's close to pi. It's not. Oh yeah, 22 sevenths. That's the Egyptians used that ratio for pi. They said pi was about 22 sevenths, I think, as their approximation. 3.14. All right, but definitely misses the rest of it. Okay, so I like that. I like using 7 times 22 over 7. That's exact. When I multiply 7 times this, the 7's cancel out. We get 22. Look at this. I want to use that. So would this work? 22, so it's 0, 7. Here's the thing. This is important. This is telling me that there is a y-intercept here at 7. So when this is 0, I would have 7. Yeah, y equals 7. So 0, we'd get 1 times 7 is 7. Yeah, no, that's not going to end up working out. Let's see here. All right, so I'm not going to do that. There's that shift of moving it up 4. Really thinking through this. I kind of want to put this into Desmos. I'm going to do that. Put it in Desmos and see if this is one that works. So, don't worry, you're just looking at my hairy little arm here while you're waiting. This is what the answer says here, but I'm going to type in y. I got it. Y equals 22 divided by 7 raised to the power of x, and then adding 4. Now, what am I doing? I'm trying to see, does it go through the coordinates that we want? No, it's not going through there. All right, well, my brain's not thinking of it right now. We're at 20 minutes long for a video. Here's the answer for this one. I guess the question is like this growth factor. Yeah, something's my brain ain't working. My brain ain't working for figuring out how do we get from these coordinates, knowing that y-intercept, knowing how this affects it. But they're saying it's 3 times 6 to the power of x. Again, my brain ain't getting there. Take care, folks. Bye.